And I'm going to say a word, and I don't want you to giggle, and I don't want you to be offended, but this is a word that's used in physics. So let me read it out loud. It says a constant retarding torque. Now what that means is it's a torque that slows something down, right? That's all that it means. It's a torque that opposes the motion of an object in rotation. So a constant retarding torque of 12 meter-newtons stops a rolling wheel a diameter of 0.8 meters in a distance of 15 meters. How much work is done by the torque? So let's draw a picture. Problem number 47. And so we've got a wheel. And that wheel, according to my notes, had a diameter of 0.8 meters. So the diameter was equal to 0.8 meters. So my radius is what? 0.4 meters. Okay? It had a torque. So if this was moving in this direction, it had a torque force that opposed it, right? And that torque force that opposed it, that's what they mean when they say retarding torque, of 12 newton meters. So they had a torque of 12 meter newtons. Okay, it's kind of hard to say. And the distance that it took, so this thing's rolling, and at 15 meters, it stopped. All right? And the question was, how much work was done by the torque? So work can be calculated a lot of ways. So let's start with the basics. So if you look in your textbook, let's see in your physics, and we've got to get used to this. So I'm going to try to incorporate this more so than me just kind of doing just writing down the answers or the formulas for you. Turn to page 300. And on page 300, we said that one way that you could calculate work is, work is equal to the radius, oh no, it's tau theta. Why do I always write that down? It's the torque times theta, right? So work is equal to the torque times theta. Oh, I see why they gave us the diameter. All right. So do I know what the torque is? Do I know how many? So do I know what theta is? I kind of gave you a clue as to what we do. The answer is no. We don't know exactly what theta is, but what we know is that the diameter of this circular object is going to roll for 15 meters, right? So now how do I convert that into revolutions? And remember that one revolution is equal to 2 pi. How do I make those conversions? What do you guys suggest? Well, where I would start is I would say that the arc length is equal to the radius times theta. All right? Well, if I take this and I solve for theta, I could say that theta is equal to the radius, or I'm sorry, it's equal to the arc length s divided by the radius. Is that right? What's the arc length? Well, the arc length is the same as the distance traveled, isn't it? If I were to cut that, if I were to slice that wheel open and lay it flat, I'd have to, it would be more like a meter stick. I might have to rotate it more than once. But we said that this is really the arc length, isn't it? If there's no slipping, and I think it may have defined it that way in the question. But we can make that assumption if they don't. Do we know what the radius is? Yeah. So I'm going to say that work is equal to torque times the arc length divided by the radius. In other words, I'm going to say 12 meter newtons times 15 meters over the radius, which is 0.4 meters. And that's the work. Does that make sense? Now the meters cancel here, and I don't know if you remember this or not, but like Newton meters or meter newtons, those are joules, right? You guys realize that? And work is measured in energy, and energy is joules. So I won't go through that conversion. We'll just skip that for now. So I'm just going to plug this in the calculator, and let's see what number we get. Well, we get 12 times 15 divided by 0.4, and I get 4,650 joules. All right.
The 155.
Oh, I thought that was a little high. Did you tell? I was like looking at my notes. I was like, that seems a little high. I hit the calculator a little too. I hit the button too aggressively, right? It's 12 times 15 divided by 4. All right, there we go. Oh. 0.4. Okay, that's what it is. 12 times 15 divided by 0.4. Oh, let's see what we get. All right, 450. So now I probably could write that in scientific notation. It's 450 joules. And that's the same as 4.5. That looks horrible. 4.5 times 10 to the 2 joules. Does that make sense? Any questions on that?